Hello, and welcome to the 3rd Annual Institute of Navigation Autonomous Snowplow Competition. 8 teams from leading Midwestern universities are competing this year, and they've spent thousands of hours designing, building, and putting the finishing touches on their autonomous robots. By autonomous, we mean the robots make all the decisions as to where they go once the student simply turns on the switch. Some of the technologies these students are developing can and will become the future of snow management. Students that have competed here in the past have already begun careers inside leading technology companies like those that have helped us make this competition possible. Last night, our panel of scientific professionals heard the technical presentations from each of the 8 teams, including 2-time champion Ohio University, back again this year with their robot Max, who navigates with scanning laser beams. Let's hear what the Ohio team has to say about the competition they face this year.
It's always very nice to see all these different approaches, and I think that's very exciting. People using vision, people using GPS, and we're using a laser. Sometimes GPS is the perfect tool, but here it's a laser may be the answer. Laser that we use is super accurate and is very hard to fool. I think this year we'll see that other teams will be using some of those elements, making their robots more robust. So I hope that this year the results will be a lot closer, and hopefully that next year's competition will throw in some new challenges that put us back onto the drawing board and invites us to get real creative with new solutions.
We lost GPS satellites in the very beginning, but luckily we did a restart and we had enough satellites for positioning fixed in. So we're pretty happy with the amount of snow we cleared and the amount of time we did it in. We use a Topcon differential GPS for our positioning. We use a microstring IMU for our heading, and we fall back in odometry. We have some wheel encoders on our motors if we lose GPS. So this is our computer. We have an i7 running Linux, Ubuntu, and this material is it's shatter resistant. It's polycarbonate. It's actually bulletproof. So the whole thing weighs about 550 pounds, give or take.
All of our technology is all based off a Windows computer. It's a simple, cheap webcam that we're using, running straight to the computer to do a little bit of processing on it, and it goes right to the wheels. All it does is look for the red line on the ground. So it's a simple track the line robot. From the computer, there's a little wire to our motor controller, and that'll run down to our motors through all the wires underneath here. All down to earth, really easy to fix. So our turnaround time when something goes wrong is really minimal.
What you learn in the book gives them the theory that tells them why things work the way they do. But until they come and actually do it in practice, it's all math and calculus and engineering. I mean, engineering is not something they touch and feel like they do here. And this competition really brings out the best. This is a team spirit. I mean, what's the most important thing they get out of this is the team spirit. They know no one person is going to be able to do this. So it means that they need the entire team working as a team.
Ask Yeti. Ask Yeti. Get the weight. Get the weight. 负重.
No. We can't put anything on right now.
We're very dependent on Novatel differential GPS. That's a huge part of our technology. We're running a Intel i3 as our main processor with a National Instruments Stereo working at the low level. That's our main computer. Underneath we have a custom breakout board that does our sensor integration. There's a Robotech motor controller at the very bottom there. It's one of the older models. We prefer that. There are voltage regulators on the other side and National Instruments Stereo to do the low-level control.
Well, the main navigation system that we have is it's a LiDAR. So that's basically a laser that'll spin in 360 degrees. So with our beacons, which we use 8 of them, and we place them in strategic locations around the field, we can get like an absolute reference frame of wherever the robot's at relative to the beacons. This combines elements of all sorts of different engineering. So not only the electrical engineering, computer science with programming, the mechanical aspect of building the robot, there's also the organization and management aspects of the project, so, and the teamwork. So all of that combines to a very beneficial experience.
Not only are the students gaining valuable experience, we in the general public are getting closer to enjoying a hot cup of cocoa inside while a robot plows the driveway. The technology being developed here at this competition is going into future automated systems for planes, cars, lawnmowers, and of course, snowplows. Here's what some of our sponsors are saying.
Local events and events that benefit the state and the region. And ultimately, it's a matter of connecting Toro and our brand with ultimately our customers.
People is one of the big things that we at Honeywell provide. The other thing is money. It encourages the schools to come. This year we've raised the competition award levels. We're giving out awards for the first 6 places. First place will be $5,000 this year. So that sponsorship money helps us do that, helps attract more schools. Hopefully we'll get this competition to be bigger, make it more complicated, more interesting things, problems for the robots to solve, those kinds of things.
I think the technology the students are learning now, they'll carry forward into their careers. And who knows what kind of clever concepts they're going to come up with and clever things to automate to make life a little easier.
And that's always a good thing to have additional volunteers to help us with the execution of the program, even if it's only for the 3-day period of the competition.
We're a small aerospace research firm, and we like to be able to on the cutting edge of navigation technologies, which includes aviation and medical and spacecraft navigation. But we're also ourselves looking for talented students that eventually can come into our company and participate and contribute to our ongoing practices.
You know, aside from it being fun for me to come down here and judge and something interesting for the guys to do and see some cool technology, we kind of get to keep our eyes on the student population that are working on the technologies that we are interested in, and sometimes that can turn into a job position for them someday if we're attracted to what we see.
The Institute of Navigation is hard at work promoting collegiate science, technology, engineering, and math. These competitions are integral in the growth of new scientific ideas and concepts which will eventually affect all of our lives.